Yeah, I would request please switch off your or mute your microphones, all of you, so that when you actually have to answer something, then you can unmute and answer. But for now, please mute your microphones. Okay. All right, fine. So let's talk about what we did in the last class, and then we'll continue. All right. So in the last class, we discussed what exactly a program is made up of. So I told you that there are two important parts of a program, right? And one of them is called as data, and the other one is the process. Depending on what is important for us, we decide the programming language. So there are two kinds of programming language, and you know it very well. One is the procedure-oriented programming language, and the other one is object-oriented. So what we are going to learn in this semester is procedure-oriented programming language and the concepts associated with it, right? So we will talk about the basic fundamental programming concepts, and we will be using all the concepts, and we will be implementing those concepts using C. Okay. Along with this theory class, you also have a practical class where where you're going to execute the programs in C. Okay. So that was what we had done in the last class. All right. So let's talk a little bit more about programming, right? And when we talk about programming, there are certain aspects that we must remember. First of all, right, we know that programming is all about solving problems, right? Last time you had told that, using a program, we try to solve problems. Yes. Now, when you talk about a problem, it can be any kind of problem. It can be a logical problem. It can be a problem which is related to, some kind of scenario where you want to do things faster. All right. So when we talk in terms of programming, right, a program is nothing but a small piece of code. It's like a small machine, right? What's a small machine? A machine is anything which does things for you, which probably makes things easy for you, right? So if you have a washing machine at home, it's not that you cannot wash your own clothes, but washing machine makes your life easy, isn't it? So for example, all of you know that vending machine, right? All of you must have, had coffee from a vending machine. So what is a vending machine? A coffee vending machine is a simple machine where, you put in something, like the coffee doesn't come for free, right? You don't have a machine where you take the cup and, unlimited coffee you can drink. That machine will want something from you. So coffee vending machine is a simple machine which accepts something. What does it accept? It accepts some input, and on the basis of that input, it is going to give you some output. And what is that output? Output is nothing but the stuff that we actually want that machine to do for us. So if you want to drink coffee, you have to go to the machine, you have to give the input. What will be the input? It will be in the form of some data. What data will you input to the machine? Number one, you're going to input some amount of money. So if the coffee costs like 20 rupees, you have to first insert the 20 rupees into the vending machine. Then you have to press a button saying that, okay, I want coffee, because there could be some other options also in that machine. There could be an option for soup, or there could be an option for juice or for tea. So you have to select the appropriate input. So assuming that I want coffee, I will put in 20 rupees, and then I will press the button for coffee. So what I'm doing here is I'm providing that machine with an input, right? And then that machine does some processing, right? As soon as the input is correct and the machine registers it, it starts doing some processing. Once that processing is completed, right, what you get is an output. What is that output? You will find that in the cup, the coffee is poured and it's ready for you to drink. Now, if you look at a coffee vending machine, that's exactly how a program works, right? A program has got some processing logic. It has got some processing logic. It has a mechanism by which you can supply it with some input, because a processing logic will only work when you give some input to it, when you request for a specific task, right? And why are you doing why are you doing the entire processing? Why are you using the program? Because you want something useful at the end of it. So a program also gives you an output. So a program can be simply thought of as a simple machine, right, which accepts some input, it has some processing logic, and it also gives some output. All right. So when you talk about, the processing logic, when you talk about the different types of processes, right, when you talk about how those processing has to be, streamlined or structured, right, we introduce a term, we introduce something called as an algorithm. Anybody knows what's an algorithm? Can you tell me what exactly is the meaning of the word algorithm? Anyone? You can unmute yourself and say if you actually know what is an algorithm. Okay, fine. Since nobody is answering, let me just continue. So algorithm
Sir, it's
is
a set of
basically,
rules.
yeah, absolutely. It's a set of rules. Yes, absolutely. I agree with it. So what exactly is algorithm? An algorithm is a set of rules, that was somebody said. But algorithm is a sequence of instructions. So when you look at an algorithm, you're talking about how your code has to be written. So algorithm is that sequence of instructions designed in such a way that if the instructions are executed in a specific sequence, you will get your desired result. Okay, and those instructions should not be, all over the place. They should be absolutely precise, they should be absolutely concise, and the result should be obtained after a finite execution of steps. That means when you define an algorithm, it's basically you are defining some sequence of instructions in a very concise way, in a very finite way, right, to obtain the desired result. That means if you're defining the algorithm, it should not repeat one or more instructions infinitely. It should not happen that there are some instructions which you are executing again and again and again and again till infinite. Because if it happens, then the program will never stop. That means the machine will keep on running till it exhausts itself. So at some point of time, the algorithm should terminate. Your sequence of instructions should terminate at some point of time, and the result should be the desired output, right? So if you look at an algorithm, it should possess some characteristics. What is the characteristics? So each and every instruction should be precise and clear, right? Everything should be crystal clear. Each instructions must be performed, in a finite number of times. You should not have it infinite. The algorithm should, terminate at one point of time, right? And when the algorithm terminate, the desired result should be obtained. So that means when you're writing a program, before the program has to be written, we must define, or we must think about and analyze the sequence of instructions in the form of an algorithm. Okay, and the algorithm should start somewhere, it should end somewhere, and it should be very clearly written. And all those steps, if you actually proceed to do using your programming language, it should actually give you the intended result. So did you understand what's an algorithm in a nutshell? Yes. So algorithms are nothing which has some kind of a technical code or something. It's not defined by the programming language. Algorithm is not constrained by a programming language. It has a very generic form. That means you can take an algorithm that you've written and you can replicate in any programming language. Okay, so did you all understand what's an algorithm in a very in a summarized form? Because there are lots of when you actually study the chapter on algorithm, there are going to be lots of things that you have to worry about. Okay, but for now you just remember that algorithm is nothing but a sequence of instructions designed in such a way that if those sequences are executed in a specific order, you will get your results. Is it clear?
Yes, sir.
Yes, sir.
Okay. Yes, sir. Okay, great. Now, what happens, when you write an algorithm, it's written in the form of a text. It's written in the form of a text. So algorithms are written in the form of a text. But sometimes it's important, or it's easy for us to understand a diagram, right? So if you have anything which is written in the text form, it is little bit difficult to understand, but when you convert it into a diagram, right, you can easily understand. Diagrams are very easily understood. So when before we start doing the coding, it is very necessary to plan, the step-by-step solution to your problem before we actually get into the code. And this plan has to be first. So before we actually start planning, you will have to think about the algorithm. We'll have to write the algorithm in a very simple form, right? It has to be written in a textual form using English words, right? And after that, you can take that algorithm and you can convert it into a symbolic diagram. You can convert it into a diagram because it's easier to understand a diagram than a text. So if you write something as a tree, right, so you have to read this and then you have to visualize it, that, oh, I'm talking about the tree. But if you see a picture of a tree, it's very easy to understand. Without even thinking, without even analyzing, you can figure out that that's a tree. Because that's why they say when you read a book, right, you'll have to imagine everything yourself, which takes time. Right, when you're reading a book, you have to imagine everything. The scene will be there, but you will have to imagine the scene in your own way. But if you are watching a movie, then you don't have to imagine anything because everything is given right there. So it's easier to understand a movie than to read a book. It's easier to understand a diagram than to read text. Okay, so what we do is, before we actually start writing the code, it is necessary to kind of plan the solution or the task for the algorithm. And it's a good idea to represent it in a diagram. So there is a diagram which is very commonly used across the world, and that diagram is called as a flow chart. Have you all heard about a flow chart?
Yes, sir.
Yes, sir. Yes, sir.
Yes, absolutely.
Yes, sir.
So flowcharts are used by all the programmers. Okay. So if you are going into programming, you must know what is a flowchart and how to draw it. Okay. Flowchart is very important for a programmer. What it actually tells you is, flowchart will tell you, it shows the structure of the program basically. It also, gives uh, the logical flow. It also tells you the operations that needs to be performed. For example, when we had discussed about programming and how programming is simple, if you remember, we had talked about three things, right? We had talked about instructions, straight, simple instructions. We had also talked about something called as branching, right? And we had talked about looping. Now, all these three things can be represented using a program. Okay, so when we are talking here, we are talking about the process. Along with the process, we also have to fit in the data. So a flowchart is a diagram by which I can represent the data, I can represent the process, and in the process, I can represent all the three. That means simple instructions, your branching, as well as your looping. Okay, so let's see what are the important part of a flowchart. So before we actually draw the flowchart, we will look at the symbols, because if you have a diagram to draw, then you know that you need to have a symbol for it. So some of the basic symbols of a flowchart, which I actually can, you guys please take note, okay? You just, whatever I am teaching you right now, please keep scribbling in your book so that you are also engaged. All right. So first symbol is the start symbol. Okay, so if this means that we are going to start the execution. Okay, these are called as terminal symbols. And there is another symbol called as stop. So these are called as terminal symbols. Okay, terminal. That means start, stop. They are the two endpoints. Now, if you have to take some input data, right, input data, or if you have to give an output, then that is represented using a parallelogram. So any input or output is represented by a parallelogram. All right. Then any kind of processing is represented by a rectangle. Please take a note of these symbols. Okay, you have a diamond. Now this diamond represents what? A decision box. What is a decision box? Decision box is nothing but your condition that when you're talking about branching, right? We talked about a branching has to be done based on a specific condition. Okay, so this condition is represented by a decision box. So all the conditions that you specify here will be written inside this decision box. Okay, then you have an arrow. The arrow can be in any direction. Okay, they are called as flow lines. What are flow lines? They will tell you in which direction the instructions and the processing, which is the sequence in which the instructions are flowing. Okay, and the last one which is important is this. Okay, so this is the symbol for a connector. Connectors. What is the role of a connector? So the role of a connector is when suppose you're drawing a flowchart and the page, you come to the end of the page, but your flowchart is not complete. So you can use a connector and you can go to the next page. Okay, suppose we so you can write A here and you can continue in the next page from here. So A. Okay, so this will come first and then this will come. This will be on the first page. This will be on the second page. So you know exactly that you're continuing your flowchart. So I think this is pretty much simple, and most of you must have already got an experience of drawing flowchart before. Is that correct?
Yes,
Yes,
sir.
sir.
Okay, fine. So with this, we can actually, create an algorithm. And after creating an algorithm, what we can do is we can convert it into a flowchart, and then we can convert it into a program. And that should be the sequence in which we should work. Okay, first it should be an algorithm, and after the algorithm, you should actually make a flowchart, and then after that, you should write a program for it. So let me give you an example. Let's talk about an example here. Okay, let's say we have to draw, let's say we have to write a program to add two numbers. Okay, so we are thinking about writing a program to add, sorry, two numbers. So before we actually write the program, so the program you'll be writing it C, so that you can do it in the lab. But what are the steps before we can go and write this program? First thing is write an algo, right? Write an algorithm for this, and then make a flowchart. So after you do this, then you write the program. So this is going to be, this should be the sequence in which you should approach this particular problem. So let's see how an algorithm should be. So I'm giving you a rough algorithm. So let's discuss what would be an algorithm for this particular problem. Very simple. So we should start somewhere, right? So let's say that the first step is start. So the first step is start. And in the second step, if we have to add two numbers, then we need to take those two numbers from somewhere. So let's say get two numbers. And we can also say those numbers as n1 and n2. Right? So that would be my two numbers. Then what I should do, I should add them. Right? So the next step would be add them. And what would be the fourth step? Print the sum. Right? Print the sum or the result. Or you can, this is also your output. And then the fifth step will be done. You are done. So this is your rough algorithm. Okay. So what you see here is your rough algorithm for this problem. Now for this, using the symbols that we had just discussed, how can we draw a flowchart? So let's see how we can draw a flowchart for this. So flowchart will start with your start symbol. Okay. And then you are accepting numbers, right? So you can say, you can either, have two separate boxes. For example, you can read the first number n1 and you can also write this read N2, you can do this, or you can also have only one box here, right? And write N1 comma N2. Both are correct, right? After you take the two numbers, what do? You have to add them. Third step is add them. So when you have to add, you have to process it, right? Adding is a step for processing it. So what do? S is equal to N1 plus N2. What is S? S is the sum of these two numbers, right? After this, what is written in the algorithm? Print the sum. So in order to print, that means it's another output. So here we used it as an input, and here I'm using it as an output. So for input and output, you use the same box. So you print S here. And after doing this, you go and write stop. Okay, so if you look at this screen, on the left hand side we have the algorithm, on the right hand side we have the flowchart for this algorithm. Now there has to be a match. There has to be a match between the left hand side algorithm as well as right hand side flowchart. And then after you have written this, then we should write the program. So now you can write the C code. So before you write any program, before you write any software or an application, you must have written an algorithm, you must have converted into a flowchart, and then you actually go and write the program. So your algorithm gives you the understanding. So after you analyze, you basically analyze your problem, you basically analyze what you need to do, what are the steps which are required to solve that problem, and then you list them down in the form of English text. After that, you do a design. That means basically when you are constructing a house, what is the process of constructing a house? You don't straight away bring in the bricks and start construction. What do? First, we think about all the requirements, isn't it? First, we think about what are the things that we need to do in a house. How many rooms do we want? Where should be the bathroom? How many windows? What would be the dimension of the room? So all that I will write it in the form of a text. Where should be my lights? How many floors should be, on the top of the ground floor? Do I need a parking? Where would be the main entrance to the door? All these things we will write it down as a requirement. After that, those requirements need to be analyzed, and after that they need to be converted into a form of a design. So an architect will prepare a design for you. So what he will do is he will make a nice diagram, and in the diagram the location of where your window is going to be, where your what is the dimension of your room, where the kitchen dimension, the bathrooms, everything will be specialized, should be specified very clearly. And after we get the design, on the basis of the design, your house is actually built. Okay, so if you look at the problem that we just did on this whiteboard, we first looked into the problem and analyzed the problem as to what are the things that we need to do. So just like how we list down the requirements for making a house, we listed this algorithm down. After that, just like how an architect makes a design for your house, the flowchart was drawn. And after that, you start implementing this flowchart using a C programming. That means my house construction starts. Okay, so this is your approach to how your programs must be written. Is this clear, everyone? Are you able to understand?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay, good. Now, what I showed you was a very simple kind of program which does not have, so we have used symbols which is start, stop, we have used processing, we have used the input and the output symbol. So there is one symbol which is important and which we have not used, and that is which is that?
Decision, sir.
Decision, absolutely. So let's look at another problem. Okay, and then let's write the small flowchart for that, and then we will draw let's write a small algorithm for that, and we will also draw the flowchart for this. So let's say that we have a problem wherein we find the greatest of two numbers. Okay, so let's do this again. So let's clear this. Okay, and we have a program to find the greatest of two numbers. Very simple. So let's write an algorithm for this. So how would the algorithm be for this? First one, you start, right? This is the most easy part. Second one, let's get the two numbers. Get the two numbers, right? Very simple. Let's say the numbers are A and B this time. Now, the third step is where we make a decision, because that's where we make a decision of what to do. So we make a decision that if the number A is greater than B, right? If the number A is greater than B, then what we need to do? Then print the number A, right? Otherwise, print B, because in that case, B will be greater than A. And that's it. So once this is our objective, so this is the main objective, and after that we stop. So this becomes my algorithm. Very, very simple, right? So now how do we actually solve this, or how do we write this in the form of a flowchart? So let's see how we can write a flowchart for this. Okay, so it's very simple. Let's start with the start, because you cannot make a mistake here, because this is the easiest of the symbols. And then we have to get the two numbers. So let's say I get the numbers. So I get means I'm going to read it. Okay, I can read which are the two numbers, A and B. Now here I need to make a decision. So I will make a decision box, right? What will be the decision? Is A greater than B? Look at this. This part and this part is matching. It's matching. Is A greater than B? Now there can be two things. If it is yes, then print A, otherwise print B. So if it is yes, do something, and if it is no, then do something else. So if it is yes, what do? We print A, and if it is no, what do? We print B, and both of them will end here. So here it stops. Very simple. So if we have to write a program to find the greatest of two numbers, the algorithm will be this one, and your flowchart would be this. And after this, you can start writing your C program. So kind of simple, isn't it? I don't think so it's complex at all. So when you talk
Yes, sir.
about an algorithm, it is very simple. All you need to do is whatever you think, when you start analyzing the problem and when you think about how to solve it, each of those steps need to be written down. And then you can go back to those steps and then check whether the steps which are written down, they are in a proper order or not. It could happen that the order of those steps are different. Then you have to arrange them in a proper way. Okay. So did you all understand this?
Yes, sir.
Yes,
Yes,
Okay.
sir.
sir.
Yes, sir.
Okay. Now, what I'm going to do is, do you know how to convert a temperature from Fahrenheit to Celsius? All of you, do you know how to convert a temperature from Fahrenheit to Celsius? Do you know?
Yes,
No?
sir. Yes, sir.
Okay. Do
Yes,
you
sir.
know what is, okay, forget that. Do you know what is the uh, formula for converting inches to centimeter? Yeah, so this is
Yes, sir.
basically, if you have a temperature in Fahrenheit, this is the formula to convert it into Celsius, right? This C is the Celsius. If you have something in centimeter and you have to convert it into inches, you have to convert this. All right, so this is the formula to convert from centimeter to inches. So if I give you like 2 inches, you have to multiply it with 2.54 to get the
54.
centimeter value. If I give you 32 degrees centigrade, so you will have to use this formula and get the in Fahrenheit. All right. So I want you to take 2 minutes or 5 minutes of your time, write an algorithm for this. Okay, so you need to write an algorithm to convert temperature from Celsius to Fahrenheit and write another algorithm to convert inches to centimeter. I'm giving you 2 minutes of time. Just quickly write the algorithm and draw the flowchart. Okay, I'm going to give
Sir,
you 2 minutes of time. Yes.
sir, Fahrenheit to Celsius.
Yes, Fahrenheit to Celsius, Celsius to Fahrenheit. Celsius to Fahrenheit and inches to centimeter. Are you all getting me? Are you
Yes,
all
sir.
there? Okay, so I'm giving you
Yes.
2 minutes time. It'll hardly take 2 minutes of time, or let's say I'm giving you 3 minutes of time. I'm going on mute. So after that, uh, quickly finish it. Come on. Just write an algorithm and the flowchart. Write an algorithm and the flowchart. Okay, how many of you have completed it? Anyone has completed it?
Yes, sir.
Okay, good, good. Now, the reason I gave you this problem is because here things are little different. Okay, things are little different. So I just want you to compare your algorithm with the one which I am writing. So the first program is convert. The first problem is convert temperature which is given in Celsius, right, to convert temperature which is given in Celsius to Fahrenheit. Now the important thing here, and the formula, let's write the formula also. So formula is equal to 9, multiply this with C divided by 5, right? And you add 32. So this is the formula. Now let's see how we approach this. Now if you look at this problem, it is not like the problem which we had discussed earlier. Why? Because in our earlier problems, we were taking the two values as an input and doing some kind of processing with them. But in this case, we are taking only one. Okay, we are only taking one, and then we are converting it, and we are taking the output and we are inserting into the another one, right? So let's look at an algorithm for this. All of you, please follow this. Okay, so how does an algorithm for this look like? So first thing, obviously, we will start, right? Second thing, now here things will be a little different. Now we have to create two different, members. That means we have to create two data, which is going to store the value of Fahrenheit and Celsius, right? So let's create the variables, or you can also write data item. Okay, one will be F, and let's say another one is C. Okay, this one F for storing the what you call temperature in Fahrenheit, and C for storing the temperature in Celsius. Now what we're going to do is, in the third step, we are going to read or accept the value of C. That means we are going to accept the value of Celsius, right? And we are going to accept that value of C into the variable C, Celsius. After that, in the fourth step, we are going to compute. Now, this is the processing step. Compute the degrees in Fahrenheit, right? And we need to put this into F. That is, F is that data which we have declared here. And then the fifth step will be, we are going to print the result. That is what we're going to print. We're going to print F, and the sixth step will be stop, or that's it. So this would be my algorithm for this simple problem. Now, how do we solve it? Using a flowchart. How do we draw a flowchart for this? Let's look at this. Okay, so how do we draw a flowchart for this? Very simple. So we start, right? And this is the simplest for a flowchart. So we start. Now, what we are doing is, we are taking two variables F, and we are also taking C, right? And nothing is there in F and C. That means when we actually take these two variables, we are using empty, it's like taking empty vessels, right? And in the empty vessels, there is nothing. There will be two cups which has got nothing right now, right? So let's take a cup F and C, and both the cups are similar, and we don't have anything in the cup, so we insert it into 0. Insert it with the value 0. That means we are just initializing the two different holders or the cups, okay, or the variables. Now later on we'll be adding values into this. So let's look at the third step. In the third step, we have written read or accept the value of C. So let's read the value of C. What is the fourth step? The fourth step says compute the degrees in Fahrenheit. So in the fourth step, we compute the degrees. So it's a processing. So we compute it. So what's the formula? 9. You multiply it with C by 5. And then you take the whole thing and add 32. After that, what you do? You print. So we use this and write print. What do we print? F, right? And then you stop.
Sir, it
Okay.
will be F is equal to,
F.
right?
Sorry. I made a mistake. Sorry. This will be F. F. Okay. Here we go. Good. Okay. So now the whole purpose of this is, right, whatever algorithm that you write, the flowchart should be identical to the algorithm. So the steps that you have defined in your algorithm must match the steps that is written in the flowchart. Okay. So the whole point was to understand what exactly is a flowchart, what exactly is an algorithm, and before we go and write a program, how do we draw and write the algorithm? Yes,
Sir,
somebody wants to say something?
sir.
Yes,
Sir,
Ankit.
can we put this Fahrenheit formula into algo in step 4?
Can you put the
Fahrenheit formula in algorithm in step 4.
in the 4? Yes, you can put. You can write the algorithm there if you want. If you want the formula, right? You can write compute the degrees in Fahrenheit. Then you can even write saying like this, using the formula, right? F is equal to 9 into C by 5 plus 32. You can write this. No problem.
Okay, sir.
Okay.
Yes, sir.
Okay, fine. Please, can you mute your microphone? Thank you. All right, so anyone has a doubt? We have just discussed how we can write an algorithm. So algorithm has to be written in a form which is easy to understand. It should be in the English form using the English words. Flowchart is a diagrammatic representation of an algorithm, right? And then after making the flowchart and writing the algorithm, then you should proceed with writing a C program. So everybody okay till now? Any doubts? Are you all understanding what I'm saying?
Yes, sir. Fine.
Yes, sir.
Okay,
Yes, sir.
fine. Fine. So let's move to a little bit about, let's move, let's close this stuff and let's look at how we actually run a C program. Okay. So when you talk about a programming language, there are certain components which are built into it. And I had discussed those components in the last class. Actually, I had not discussed it, but I had given you those names. Okay. So when we talk about a C programming language, right? C programming language, or for that matter, even when we talk about C++, these are the following components which actually run behind the scene. So these are the components which will be useful for you to run this program. Okay, I'm going to list them down. So I'm not listing them down in any order, but we will try and structure it to an order. Let's talk about, all of you know this word. All of you know this compiler, right? Everybody knows about a compiler. Let's bring about another word. All of you, have you heard about this? Just tell me whether you've heard about it. Yes or no?
Yes, sir.
You've heard about it.
Yes, sir.
Okay.
Yes, sir.
How many of you have heard about this word? Yes, you've heard about it?
No, sir.
No. Okay. How many of you have heard about this word?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, good.
Yes, sir.
How many of you heard about this word?
No, sir.
No? Okay.
No, sir.
No problem. Now just remember that when you write your C or C++ programming, or when you write a C++ program, these are the guys, okay? These are the components which will actually work behind the scene for you to execute your programs, okay? So in order to execute your programs, in order to run the C++ programs, these are the components which are actually useful. You must have also heard about a component called as interpreter. Okay, interpreter. So those guys who are into Java, you should probably, those of you who know Java, you must be familiar with this word interpreter, but we will not
Yes,
discuss
sir.
this in C because in C we do not have an interpreter. Okay, in Java we have an interpreter. Okay, so in C and C++, these are the components which actually help us in executing our programs right from the beginning, in creating a program to execution of a program. Now, all of you have heard about this word compiler, right? Now, we need to know about preprocessor, we need to know about assembler, we need to know a little bit about linker and a loader. Okay. Now, what I'm going to tell you is, I'm going to draw a flowchart now. I'm going to draw a flowchart. And in the flowchart, through the flowchart, you will probably understand how all these components work. So I would also request you to please take take note of whatever I'm drawing so that you also can refer to it later. So this is how this is a flowchart for a C program. Okay, so let's write it down. So this is a flowchart for a C program. And I'm going to introduce all those components there. So you basically write the program. So you write your, so I'll start from this corner. So you write your source code, right? So you write your code, this is where you write. Okay, I'm not writing the start and the stop because it will take some space. So assuming that there is a start and a stop. After the source program is written, you know, the first component which comes into the picture is your preprocessor. Preprocessor. Okay. After the preprocessor, what comes into the picture is your compiler. Now I'll explain this to you, actually what is the work of each one of them, right? And the compiler, what it does is it checks whether there are errors. What kind of errors? Syntax error in your program. Okay, it checks whether there are syntax error in the program. So if the compiler finds that there are errors, so it checks for errors. If there are errors, yes, there are errors. What happens is we have to go back and correct that error and make changes into our source program, right? If there are no errors, that means I don't have any errors, then what happens is the linker comes into the picture. Okay? The linker comes into the picture. And after the linker, the loader comes into the picture. All right. And after the loader comes into the picture, there can be three things, right? There will be a file called as the, actually what I'll do is I will, after the linker comes into the picture, an object code is made. I'll explain this to you. Object code is made, right? This object code will give you the output, whatever is the output of this program. Now, if we find that there is, when your program is run and there is an input error, that means if the user did not enter the right value, suppose the program says enter any number between 5 to 10 and the user is entering A, then what happens? There is an error. Okay, so then we have to go back and ask the user to input again, right? And then again it goes back to the object code. Okay, now in case we find out that there is some logical error, sorry, the diagram, the symbol is not drawn properly. If there are some logical errors, we found out that there are some logical errors, then what happens is, if there are some logic errors, we go back and then again make changes to a source program. And if there are no logical errors, then we also give an output. So this step onwards, the loader comes into the picture. So if you look at it, first we have number one, we have preprocessor. Number two, we have compiler. Number three, we have the linker. Number four, we have the loader. And in between here, after the compiler, there is another step which I missed out here, which is assembler. So after the compiler, third will be the assembler, then we will have linker, and 5 will be the loader. Okay, so now I'm going to explain what exactly each one of them does. Now what happens is, when you write a file, right, preprocessor comes into the picture. First, what the preprocessor does is, it will do the pre-processing which is required before the compiler comes into the picture. What is the meaning of pre-processing? Pre-processing means, in your code, if you have done C or C++ before, we write something called as hash include. Right? We write something like this. This hash is called as preprocessor directive. That means wherever there is hash written in the code, the preprocessor will look at that line of code and it will include all the files and include all the codes which are mentioned inside this bracket. So if you write stdio.h, all the code from stdio.h will be included into your program. Okay, so preprocessor, what it does is it will look at all the lines which have hash written, right, and it will include and work only on those lines. It will get all the code from stdio.h file. It will include that into your source program. All right. Now, after that, what happens is the preprocessor finishes its work. That means when the preprocessor gets called, that time the processing of your program is not ready. Okay, it's like you are going for a picnic. So you're about to drive your car, but before you drive the car, you make all your necessary, checks. You load your luggage. So all the tasks, you load the luggage, check for tire pressure, put fuel. All these are activities which are involved like a pre-processing activity. Before you go for a drive, you check for all these things. You load your luggage, you put some petrol and all that stuff. So those are all pre-processor activities. So even before we start your processing, we have a component called as preprocessor, which does all that activity. It will load stdio.h and all the other files also which is required or which you have mentioned. After that, the compiler comes into the picture. What does a compiler do? It checks whether your file or whether the program that you have written is written in a proper grammar or not. That means it checks for syntax errors. It checks whether there are any errors in your program. Now, there can be different kinds of errors, but what the compiler checks is only your syntax errors. Okay. Along with the syntax error, the compiler also does conversion. The compiler also does conversion. It converts your high level language into assembly level language. Now, what exactly is a high level language? Now, the program that you write using your C or C++, right? Most of the code that you write is written in the form of English. Okay, English is a high level language, the one which humans can understand easily. But when you talk about the computer, right, when you talk about the computer is not able to understand this high level language. What it understands is a machine level. So it understands only 0, 1, 0, 1, this kind of, language. Now this is called as machine level language. So on one hand, we have something written in English, and here we have written in binary. So this binary is machine level language, and this is what the machine understands. But what we understand is English. So we write the code in English, and this code that is written is called as high level language. This code which the machine understands is called as machine level language. And in between this, there is something called as assembly level language. Now this assembly level language is basically an intermediate code. Okay, intermediate code meaning, that means it is not completely machine level and not completely what you call English. Okay, so what the compiler does is it will check for syntax error, and after that it will convert your C code which is written in high level language into assembly level language. Okay, now the assembler will come into the picture. What is the role of an assembler? The assembler will convert this assembly level language which the compiler has written, and then it will convert into machine level language. Are you all understanding what I'm saying here?
Yes, sir.
Yes, sir.
Okay, so the assembler will convert the assembly level language to machine level language. So the role of preprocessor is done, role of compiler is done, role of assembler is done. Now what happens is the linker comes into the picture. What the linker does is it will take all the files and all the necessary libraries. Now what happens is when you're running the program, when you're running something, you also need some support, right? You also need some support, you need some additional libraries. So for example, when the cricket match is held into a stadium, stadium, when you go for a cricket match in the stadium, that match is one aspect, right? That is the main thing. That is your program which is running. But along that cricket match, there are so many other services which are also required. What are those services? Like, for example, there will be a crew member who will be taking the video shots. There will be a maintenance team who will be looking at all the things, whether things are in proper shape or not. The light guys will be taking care whether the light is proper or not proper. There will be some recreational facilities for the players and all in the dressing room. So all these are basically your allied services, right? Now, in order to run the cricket match, everything needs to be put together. Everything needs to be put together. Your food has to come for the players. The lights have to be properly arranged, right? The television crew should be in order and they should be ready, right? The telecast, what you call the signal should be fine. The internet bandwidth, satellite systems, everything should be set up properly. So all these services, which are not directly linked to the cricket match, but they are important, they are put together. So what the linker does is, in order to execute your program, there are certain extra files and all are required. So what the linker does is, it takes everything together and links it to your program. Okay, and once this is linked together, your process of compilation and everything is completed, and you get something called as an object file. So you write your program, and then when you save that program, your program is saved using an extension .c, and this file you will put it inside a compiler for compilation. Okay, so when you take this .c file and put it for compilation, actually this preprocessor is coming into the picture, compiler comes into the picture, then assembler comes into the picture, and all these things are working behind the scene, but you don't know. Okay, after that, once the linker comes and does all the work, the final output, there will be another file generated into your system in your directory, which is your obj file. Okay, that's called as an object file. So this object file is a file which is ready to execute now. So this file can be taken for execution. Now what happens is, till here everything is happening in the compiler inside your software, C++ software. Now you have to take the file which has been compiled, which is ready, and you have to put it inside the operating system. That means you have to give it to the operating system to run, isn't it? So you have two different things. One is that, suppose you are creating something and then you will have to execute. So for example, if the ISRO, if suppose ISRO is ISRO launches rockets, right? Now there are two ways in which the work is done. First of all, the construction of the rocket takes place. Where is the construction taking place? That will be taking place in the lab, right? In their own factory, in their own institute. After that, when they have to launch it, they will be taking to the launch pad. So they will take everything that they have made and they will give it to the launch pad, and the launch pad, from the launch pad, the rocket is launched. So similarly, when you're writing a C program, all the programs, preprocessor, compiling, assembler, linking, everything is happening inside one factory. And after that, in order to launch the code, the obj file which is created is taken to the launch pad. Launch pad is where? It is the processor of your system. Who handles that processor? Who is the guy who is actually managing everything there? It's the operating system. So you basically take the obj, say loader, you see here, this is that component which interacts with the operating system and gives the file. Which file? The obj file for execution. And after that, your C program runs. Okay, so pre-processing, compilation, assembler, linker, loader. These are the 5 different components which are responsible for executing your program. So are you all okay with today's class? We learned quite a bit today, and a lot of topics were covered. We briefly discussed what an algorithm was. We looked into how to make a flowchart, and we also, in a very brief way, we discussed what are preprocessors, compiler, assembler, linker, loader. Now, the task of a compiler is not just what I told you. There is a lot of different functionalities, and you can go into details of a compiler. Compiler is a wonderful component. It has got lots of other functionalities, right? But we will not discuss it because this is specifically a programming not the in-depth of what happens at the back end. So any questions on this? Because we're already running short of time. Any questions?
No, sir.
No? Okay, fine.
Sir, can you please, elaborate loader again?
Loader.
In a
What
short.
the loader does is, loader is that component which interacts with the operating system, because when you have to run your file, you have to run the file on the processor. You have to load it onto the RAM, isn't it? Any program which actually executes on your system is first loaded into your RAM, and inside the RAM, from the RAM, it is taken into the processor and it is executed or it is run. So loader is that component which helps in loading your OBJ file or your C++ C file. That is the component which interacts with the operating system to load your file into the RAM and into the processor.
Okay, sir. Got it.
Fine. So I think we can stop here today. I think you're already running short of time. So we'll meet again tomorrow and we will continue. All right. So see you.
Yes, sir.
Bye.
Yes, sir.
Bye, sir.
Thank
Bye.
you, sir.
Thank you, sir.
Bye.
Sir, thank you, sir.
Bye.
Thank you, sir.